I'm very honored to receive this Global Energy Prize because of our invention of the Triboelectric nanogenerator. The energy we use today mostly rely on fossil energy, which is what we talk about today. But over long term, let's say in next century, what will be the energy for us? We burn oil, coal, and gas that distribute our environment. But reuse of those energy become very difficult. So what is the energy we can rely on for sustainable development of our humankind? Let's say in a couple of centuries, our invention make energy reutilization possible. So we can harvest energy from our environment and make reusable. To say how, we use two different effects. You know, traditional way use electromagnetic generator, which runs at a fast pace and fast amplitude. That's make possible. But once the energy in the environment is low frequency, low pace, use such, we need to use new effect. So we use Triboelectric effect and electricity induction. So we invented a Triboelectric nanogenerator, TENG, in 2012. Now we can utilize this one, conversion energy into electric power at efficiency as high as 50%. So then say, what is this for? We use it for wearable electronics. We can use for human-machine interfacing, solar power sensor for Internet of Things. We also use it for distributed sensor for our environmental protection. We can also use it for what? For like security, because the sensor, once you trigger any mechanical motion, it gives a signal. We also demonstrate possible to have the water wave energy in the ocean. That's the water. But once you do this one, you have a long-lasting, forever energy we need. But traditional technology make this impossible because the limitation of physics. So our new approach make energy reutilization possible. So over long term, we can hopefully generate enough power. Let's say how much you can generate. Let's say we can generate per cubic meter of water per year, 400 kilowatt hours, which is 30% more than solar from the same area. So this tremendously impact our future energy need. So we are very excited to get a recognition of the Global Energy Prize and hope this new invention, brand new invention since Faraday's time, 1831, we can have a reinvention of a new approach for energy for the future. 2005, when I was lead student to the piezoelectric effect on nanoscale, we found we can convert small energy into electric power, use nanowires, so we call nanogenerator. That's the one name comes. 2012, we found that Triboelectric can do the same thing because it was a mistake. When we do the piezoelectric effect, the device was not a good package device. We found have a better performance. After 6 months, we found the Triboelectric effect. So we eventually get rid of the piezoelectric effect, use the Triboelectric effect. So it's much more effective, much more cheap, low cost, and effective. So we'll be able to do that since that time. It was found from, then we stay on. Up to now, we have 1,000 people work on this field. So it's faster growing. It's the #1 impact of field across all fields in the world right now. The invention was made about 11 years ago. Now that we enter the phase of commercialization, so we have small companies start up, and we also have the young people engage in commercialization. And globally, have 16,000 scientists distributed in 83 countries and regions who are engaged in this research. So every year, 1,000 papers published. Okay, so ever since the beginning of this field, now it's 15,000 papers published. So we see a fast growth in many countries, including America and Europe and many other countries for that, engage in this research because they see the big potential, broad impact, as well as the innovation of our inventions. So we hope this can make a contribution to our society in the future. So we are very excited to see the great commercial opportunity in next 5-10 years to come. We started nano energy 25 years ago. At that time, nobody cares. Nobody even know what we want to do. I start with the piezoelectric effect. Until 11 years ago, we found the Triboelectric effect from accidental. We found it can do the same thing and a simpler, cheaper, better, and high performance. So since then, with our effort, complete shift to the Triboelectric nanogenerator, TENG. And so we are looking for new energy. But at that time, we don't know what we look. But once you search for it, you find a new way for possibly for solve our energy in the future. My advice to young people is, first one is be curious, be innovative, be brave, be challenging. Then once you find an area you can do something different from others, stay on, stay focused, persistency, and persistency. And sometime you can find something you can do, no other people ever thought about that. So my advice is that work hard, work talented, and work persistence. My focus for the next future is that we want to develop this one to better serve humankind. Next 5-10 years, we want to shift our attention from scientific discovery, technology innovation to commercialization. We want to see the broad impact to commercial product. Either you can use for sensors, smart cities, or infrastructure monitoring, as well as large-scale blue energy. So our focus will shift from technology innovation to commercialization. We want to do that. We want to see this new invention bring worldwide impact, as I hope. I received the prize. I feel very honored. It's a major recognition to my scientific career, to my team. I use this money. I donate to my university. I get an undergraduate degree to set up a foundation as a seed fund, and also set up a new prize. We can encourage more graduate students, more young faculty who engage in the original research and scientific discovery. So in the future, it's not only have me, we have many young ones to come. That's my goal.